Sec 3 NE Chapter 5 Coordinate Geometry TYS Questions Part 2. Now in this part of our lesson today, we'll be looking at identifying points such that the remaining points all form a parallelogram. And then we'll be finding equation of straight lines. There are three types. Horizontal straight line that cuts only the y-axis, so y equals to something. Or vertical straight line that cuts only the x-axis, so it will be x equals to something. And then last but not least, y equals to mx plus c for those slanted lines. And not only that, we will be also practicing more on the questions that we learned the last lessons. For example, like solving simultaneous equations so that we can find the points of intersection. So if you're ready, let's begin. Okay, question number 7. Inside this diagram, we have triangle ABC. A is the point negative 3, 3, B is the point negative 5, negative 1, and C is the point 5, negative 1. Some things to take note and observe. Notice that this one over here is one straight line, horizontal straight line. The y value and the y value is the same. So what do you know about this equation of this straight line? This will be y equals to negative 1. And then we have an x coordinate. This is negative 5. And then this is x coordinate 5. So do you know how many units are there from here to here? I have 5 units on this side. Another 5 units on this side. So in total, it will be from 5 to negative 5. So in total, I will have a length of 10 units. Okay, now question say the point A, B, C, and there's another point P are vertices of a parallelogram. So now they ask you to find all the different positions such that this will become a parallelogram. Now what does a parallelogram looks like? Parallelogram have sides that are opposite each other to be equal. So now one possible position A, B, C. So one possible position is that this line here have a parallel side to it. It can be on from A to the point P. So I have something that look a little bit like that to give you one parallelogram. So if I want that to be true, from this point over here, it changes by, the x coordinate changes by 10 units. So for this is from negative 3. If I were to increase this by 10 units, what will be the x coordinate of the point P1? So what I'm going to do, the y coordinate actually stays the same. You see, like this one over here, it stays the same, right? So the y coordinate stays the same. So my y will still be the number 3. But I know that my x coordinate increased by 10. So now I'm from this number, negative 3, I'm going to plus 10. So that I'll get a number 7. So first answer down here, point P1 will be the point 7, 3. Okay? Now, although we have this point, this is not the only answer. There are 3 possible type answers. Now, well, if I can have the parallel line on this side, I will also be able to have a parallel line on the other side. So, for example, this can be parallel to, instead of going to the right, I'll move now to the left, so that I'll have a parallelogram that looks like that. Correct? So, okay, if this is the case, this is my point P. Now, P2, I shall call it P2, second point. Okay, as usual, my y coordinate stays the same because it's on the same straight line. So, y coordinate stays the same. But my x coordinate, instead of moving, adding 10 units and it goes to the right, now I'm going to move to the left. How to move to the left? So instead of adding 10 units and it goes to the right, I shall subtract 10 units. So negative 3 minus 10 will give me negative 13. So this will be a parallelogram. Second point P can be negative 13, 3. Okay, now these are the 2 possible ones really using this side as the parallel sides. What happens? Where's the third point? Okay, I'm going to erase all this away. Where's my third point? My third point, instead of parallel to that side, there are two sides of a parallelogram, right? So instead of being parallel to that side, I can have and parallel to this side over here. Okay, so now if I were to be parallel to this side over here, isn't this the same diagram that we have drawn for P just now? The first one, P1, right? So this one is already the same, so we're not going to look at this. If that's the case, then maybe I can draw this length. I'm going to, instead of shifting upwards the direction, I'm going to shift downwards. So it looks something like that. Okay, this one I don't want now, so I'm going to erase it away. So now my parallelogram looks something like this. Okay, but if it's a slanted line, it's slightly harder to take note of. Okay, so I'm from point C. How do I get to these points? So I need to go downwards, right? Parallel to this side. So point C to this point, new point P3, okay, is actually parallel such that I'm moving from point A to point B. So with point A to point B, let's look at our coordinates. First one, the x coordinate. How many units do I move, okay, in order to get to from -3 to -5? If I want to move from -3 to -5, I need to subtract 2 units, isn't it? So for 5, to get to the point P, I also need to subtract 2 units. So this point P3, the coordinates will be 5 minus 3, 5 minus 2, comma, okay, which gives me the number 3 actually. So this number is 3. And then I need to move downwards from here. The y coordinate now is 3 to become -1. From 3 to go to -1, how many units is that? 3 to 0 is 3 units. 0 to 1 is 1 unit. So from this to here, I subtract 4 units down here. So that means I will also need to subtract 4 units. From -1, I'm going to subtract 4 units. So -1 minus 4, that gives me a number -5. Okay, so this one is slightly a little bit harder to understand. I repeat again, if I want this parallel sides point P here, I need to see, look at the coordinates, how many units did I shift on the x-axis direction. From -3 to the number -5, I subtract by 2. And then from the y direction, from 3 to -1, I move down 4 units, so I subtract 4 units. So that's how I got my answer. Have you gotten the concept? If that's the case, then we shall move on to the next part of this question. Now, part B of the question, find the equation of the line BC. Oh, well, we already know that BC is a horizontal line. If this is a horizontal line, which axis does it cut? Well, it cuts the y-axis, and only at which number? Which one is the y value over here? This y value is -1. So what's the equation of this line? Y equals to -1. Next one, find the equation of the line AC, correct? AC is this line over here. So what are the things we need to do in order to find equation of a straight line? Okay, number 1, we need to find, first step, the gradient. Okay, let's write down our point A and C first. I have A is -3, 3. C is the point 5, -1. Okay, so I want AC. I'm going to find gradient first. Gradient equals to, what formula? Well, y2 minus y1 over x2 minus x1. Be careful of the negative sign for this bracket over here. This will give me -4 over 8, -1/2. Okay, so now step 2, I already know the equation. The gradient is y equals to -1/2. So what's the equation that I can write? I can write y equals to mx plus c. The m is now this, and x plus a c. How do I find the c? C is the y-intercept, right? So what can we do? Well, we can sub a point. Now, which point do you want to choose? There are 3 points over here, A, B, and C. But bear in mind, only A and C lies on this line, right? So we cannot choose B. So you can either choose A or choose C. In my case, I'll just choose, let's say, point A lah, okay? Negative 3, 3. So if I have that, x is the value, negative 3, y is the value, 3. So 3 equals to negative half times 3 plus c. Okay, so this will give me 3 equals to, oh, my x is negative 3, sorry. I wrote wrongly for my x value. X is negative 3, negative 3. So negative times negative will become positive. This will become 3 over 2 plus c. C equals to 3 minus 3 over 2. Well, for algebra, we do not write mixed number, so we will have to change it into improper fraction. So in this case, I'll get 1.5, which is still 3 over 2. Then last but not least, number 3, I'm going to write down the equation. Y equals to mx plus the c is 3 over 2. Have you gotten the answer? Okay, if that's the case, now I'm going to erase this away and then use the empty space to do the answer for part C. Alright, so now we have gotten the line over here, AC to be negative half x plus 3 over 2. The line y equals to x cuts the line at a point D. Now find the coordinates of D. A point D, the coordinates of D itself, coordinates come in a pair of x and y values. I have 2 unknowns. How many equations do I need? I'll need 2 equations and I need to solve simultaneous equation. What are the 2 equations that I have? First, they tell me the line y equals to x. So equation 1, y equals to x. This is equation 1. And then equation number 2 cuts the line AC. So I use the equation for the line AC. Y equals to negative half x plus 3 over 2. That's equation number 2. Well, I notice this is already y and this is also y, right? So both of them are y. What I can do is I can substitute this directly. So y is equals to x. In my case here, I can replace this y by the letter x. I'm going to use a substitution. So this will be x is equals to negative half x plus 3 over 2. So that all my equation now only got the unknown x. So the last time we used for the other case, we do by elimination. For this time, this case is easier because y is already a subject, so we can use substitution. Okay, so now let us put the like terms on one side. I have x, and this one comes over. Remember to change sign. So become plus half x, and this is 3 over 2. So x plus x, half x, this is 1 unit of x plus another half units of x. That is 1.5 x. How to write 1.5 in improper fraction? 1.5, that's a 3 over 2x. If 3 over 2x equals to 3 over 2, therefore x must be equals to 1. Okay, so now I already gotten my coordinates here. X is equals to 1. Okay, then find my, what do I need to do now? I need to find my y value. They say y is equals to x, so y is also equals to 1. So this point will be the point 1, 1. Therefore, D is the point 1, 1. Have you gotten the concept? One more question for the day. The diagram shows the point A, B, and C. The quadrilateral ABCD is a parallelogram. Find the coordinates of the point D. Notice there's only one mark over here. So there's a particular position that they actually want. That means they want from A to B, B to C, and C to D, so that it closes up and become a parallelogram. So if that's the case, let's take a look at our diagram. I have A joined to the line B, B joined to the line C. If I need to close up the diagram, I cannot move downwards, right? This one will not be a parallelogram because the lines will cross each other. So now what I can do, I'm going to shift it upwards the other direction, right? But then that means this will have a gradient, a slanted, diagonal. How do I measure and draw this diagonal? Let's take a look. That means if I'm going to point C, I'm going to go upwards. That means it's similarly like going from point B all the way to the point A. For point B all the way to point A, let's take a look. Point B, x coordinate is 0. X coordinate for point A is 2. How many units did I shift on my x direction? From 0 to 2 is 2 units. And then I'm shifted for point Y, the Y units. So now I'm going to go upwards, right? The Y coordinate is 4, now it's 7. How many units did I shift upwards? 3. Now please do not just count only the squares, because the squares itself means sometimes one square may represent 2 units. So we don't just count the squares and add the units. We need to look at the actual x and the actual y number. So now I know that my x is a +2. So I'm going to draw a count for myself. I'm going to add 2 to my x coordinate. So for my point D, I'm going to add 2. Okay, from 9, I'm going to +2. 9 plus 2 will give me 11. And then my y value, I'm going to shift upwards. So I'm going to, by 3 units, right? So I'm going to shift upwards by 3 units. So I'm going to take my y coordinate, which is the number 5. I'm going to +3. Okay, 5 plus 3, that will give me the number 8. And then I should draw the line here, point D. Okay, so this will be the coordinates of D. Have you gotten the concept? Up next, question B. Find the equation of the line AB. So I want to find the equation of the line. What are the things that we need to do? First one, let me write down the coordinate for A. A is 2, 7. B is 0, 4. I write it down so that I don't get confused, because there's still another point C, right? So now equation of this line, number 1, I'm going to write the gradient. Gradient equals to what formula? y1 minus y2 over x1 minus x2. Now be careful of the sign. I'll have -3 divided by -2. That gives me 3 over 2. So gradient is 3 over 2. Therefore, I know my equation y equals to 3 over 2x plus c. Okay, then now I need to sub in a point. Well, we notice, what's the y-intercept over here? The y-intercept is actually 4. Okay, if not, you can also sub in the point 0, 4 and work out the answers. But I know already y-intercept is equals to 4. So therefore, my equation is y equals to 2 over 3x. Y equals to 3 over 2x plus 4. Have you gotten the answer? Alright, next one. Okay, going to find the next part of the question. Question says to find on the diagram, draw a line parallel. Parallel means what? What does parallel means? Oh, parallel means we need to draw the same gradient. Okay, same slope. Parallel to AB. What do we notice just now down here? We notice that there is a shifting of 2 units. and then shifting upwards by 3 units, right? So now they say pass through, draw a line and then pass through the point 4, 6. So first let us plot this point 4, 6. 4, 6 is down here. If I want it to be parallel, they must share the same type of gradient. That means I will also need to shift 2 units, shift 3 units down here, mark another point. Okay, but this one is 0.46, right? Oh, this point cannot be seen. If not, they will think that we draw a wrong answer, right? So this point will be just slightly dot for a while. And they want us to draw a line. So I'm going to use this point to help myself to draw one straight line. Okay, so it will look something like that. Okay, please use your ruler. I don't have a ruler, so I can't do it. Don't have a ruler on my diagram. Okay, so this is the line that is parallel to AB and passes through the point 4, 6. So this answer for part C. Label our answers in case they can't see it. Okay, now part D. Find the length of BC. B is the 0.04. C is the 0.95. So how do we find the length? We need to use Pythagoras theorem. So BC is equals to something square plus something square. So we'll have y2 minus y1, x2 minus x1. So that will be square root of 9 square plus 1 square, and that gives me 9.0554. Rounded off 9.06 units. 3SF. Have you gotten the concept? Okay, we are nearing to the end of our today's lesson. So let's just recap a little bit on things that we have learned for today. So now if you have points of a parallelogram that you need to find. So for example, if I'm given a line AB and I want to form a parallelogram, then I'll need to count the horizontal units, change in the x-coordinate, and the horizontal change and the vertical change in the y units, okay, so that we can use it to draw, let's say, another point D is given, and we can find point C, and we need to go up. So you need to shift, let's say, the same x amount of units and same y amount of units in order to find the point C, such that A, B, C, and D will be a parallelogram. So this is the x units and this is the y units. Okay, next one, we also need to find equations of straight line, and mostly in today's cases, we all have horizontal lines, y equals to something. Okay, if it's a vertical line, please bear in mind it cuts only the x-axis, then that will be x equals to something. And then last but not least, we tried to solve simultaneous equation to find the coordinates of the points of intersection. Coordinates of intersection have x and y value. We need 2 equations to find the 2 answers. So therefore, we need to solve simultaneous equation. And adding on, just now we also learned how to draw a line that is parallel, okay, to a particular line. And parallel actually means they have the same gradient, same slope. Alright? So this is what we have done for today's lesson. See you around for the next lesson.